Hi and welcome to Chemipedia chemistry classes for 11th and 12th standard. So in this video, I'm going to discuss about the rate determining step. So what is rate determining step? The step which occurs slowly in a multiple step process is called as rate determining step. So we have a chemical reaction which occurs in several steps, which is nothing but a multiple step process. So each step is occurring with different time. Each step is taking different time. So among the multiple steps, the step which goes very slowly or the step which consumes more time is what we call it as rate determining step. So that's what the definition. The step which occurs slowly in a multiple step process. Step occurs slowly in a multiple step process is what we call it as rate determining step, or otherwise that can be defined in another way as the step which has low rate. The one which is going slowly has less rate or low rate, isn't it? The step which has low rate in a multiple step process is what we call it as rate determining step. Okay, so let us understand the rate determining step with some examples. Let's have an example: decomposition of hydrogen peroxide in presence of catalyst iodine. Okay, right. Actually, this hydrogen peroxide dissociation occurs in two steps. The first step is nothing but the hydrogen peroxide, which is in aqueous form, reacts with I minus iodide ion. Okay, it's giving here what is happening is oxygen from hydrogen peroxide will be added with I minus, so that you are getting IO minus. Once oxygen is removed from this, probably you get H2O liquid. Okay, so this is the first step. Hydrogen peroxide reacts with I minus ion, giving water liquid plus IO minus. Okay, right. Then the second step, the another molecule of hydrogen peroxide reacts with IO minus. Okay, now again transfer of oxygen. One oxygen will be added with this oxygen, so that becomes as O2. Then I minus is getting separated. When this hydrogen peroxide loses the oxygen, so it becomes as water. Okay, right. Probably the net reaction will be nothing but this IO minus and IO minus getting cancelled, isn't it? And this I minus and I minus will be cancelled. Now what is left is, left side you have twice hydrogen peroxide on dissociation, giving right side one water molecule here, another one twice H2O plus O2. So this is nothing but the overall reaction of dissociation of hydrogen peroxide which occurs in presence of iodine catalyst. Okay, right. Now in these two steps, the first step takes more time. The first step is going very slowly, whereas the second step is fast. So that among these two steps, the most of the time will be consumed by the first step. Therefore the first step is what we call it as rate determining step. Okay, so the step 1 is rate determining step because it goes slowly. So this is one example. Let us understand this clearly with another example. Example number 2 is nothing but nucleophilic substitution reaction of alkyl halide. Nucleophilic substitution reaction of alkyl halide. Okay, right. Here we have tertiary butyl bromide. What's that? This one is nothing but tertiary butyl bromide. With that, when we add sodium hydroxide, so now what will happen is the OH minus nucleophile will come and substitute Br minus nucleophile. That is how it is a nucleophilic substitution reaction. So as a result of that, you are getting tertiary butyl alcohol. This is nothing but tertiary butyl alcohol with byproduct sodium bromide. Or otherwise, you can say that Na plus and Br minus are getting combined together, so form sodium bromide, and OH replaces bromine, so that you are getting an alcohol as a product. But tertiary butyl bromide giving tertiary butyl alcohol. Okay, this is next example. Now like previous example, even this reaction also occurs in two steps. The first step is nothing but formation of carbocation. So I have written the tertiary butyl bromide structural formula. Here there is a covalent bond between carbon and bromine, isn't it? Right. Between carbon and bromine is more electronegative than carbon. But now what will happen is this bromine atom will pull the bond pair towards itself. Being a more electronegative one, it pulls the bond pair towards itself, so that it will go out as Br minus. So that here the carbon, this carbon is losing the electron, so it gets a positive charge C plus. A carbon with a positive charge is what we call it as carbocation. The name of this carbocation is tertiary butyl carbocation. What is this called? tertiary butyl carbocation. That's what the first step, formation of tertiary butyl carbocation. This step occurs slowly. The first step occurs slowly. The next step, nucleophilic attack. Once you get a carbocation, the OH minus nucleophile. Actually, we do this in presence of sodium hydroxide, isn't it? That sodium hydroxide will produce OH minus nucleophile. That OH minus nucleophile can readily attack that C plus carbon, because C plus carbon is electron deficient. The nucleophile OH minus is electron rich. So the electron rich nucleophile OH minus can readily attack C plus carbon, so that it makes a new bond. COH bond is formed. Okay. Whereas this nucleophilic attack occurs at a fast rate. So finally you are getting the product tertiary butyl alcohol, isn't it? Okay, right. Now when you compare these two steps of this nucleophilic substitution reaction, step 1 occurs slowly, step 2 is fast. Once you get carbocation, immediately you will get the alcohol, but the formation of carbocation takes some time, so it occurs slowly. So that the first step of this reaction, that is carbocation formation, step 1, carbocation formation step, is occurring slowly, and it is called as rate determining step. Okay, right. So I hope you understood what is meant by rate determining step. Okay, right. Thank you.